This lesson is over subtracting equations. So yesterday we talked about, excuse me, addition equations, which is something like, not like that, let me take my pen out, x plus 2 equals 3. But what happens when we have x minus something, say 4, equals 7? We can't demonstrate minus a positive number within an equation. So we have to use negative counters. This is the same thing as x plus negative 2 equals 5. If you think about add the opposite that we did earlier, this is also the same thing as x minus 2. So really, whenever you see this minus 2, you should almost be thinking of it automatically as a negative instead of a subtraction sign. So on this problem, we're going to do x minus 2 equals 3. So x is going to be my trash can, and I'm going to put, for the minus 2, I'm going to put 2 negatives. So add the opposite. And that should equal, I'm going to use a balanced scale because I don't want any symbols, a positive 3. On this one, again, I'm going to add the opposite. And for my balanced scale, I should have an x and 8 negatives. My scale really isn't big enough. And that should equal 4 positives. So that's the modeling process. We always change these subtraction problems to addition. Give me just a second. Forgetting where I'm going. So we're going to model these using our 3-box method. So again, we're going it takes too long to do this, so I'm just going to draw it in. But we're going to change this to an addition problem first. And then this first should be your model, just the original equation. So I'm going to draw x, and then I'm going to draw negative 6 counters. And positive 7. Counters. In the next box, we have to have our original equation, but remember this box is actually for showing your step. So how do you think we're going to get rid of those positive counters, or sorry, those negative counters? Yesterday we got rid of positives with negatives, so today we're going to get rid of negatives with positives. So I'm going to add 6 to each side. And these are all going to go away, which means x is equal to 3, 6, 9, 12, that's 13. Okay. So again, this is your step, and this is your answer. Let's try another one. I'm going to change this to an addition problem using add the opposite. So I'm going to have an x, negative 3, and negative 4. How do I get rid of negative 3? With positive 3. Oops, sorry, I'm supposed to show my step in the next box, so let me fix that. Okay, so here's my model, and then of course I need to redraw it down here. And how do I get rid of negative 3? With positive 3. So what's left goes in my answer box. All of this is gone. These all cancel out as well. And I just have negative 1 left. Okay. Now sometimes you're just going to have to do it algebraically, which means the actual math steps. So remember, this is the same thing as x plus a negative 2. So how do you get rid of negatives? with positives. So you show that you add 2 to both sides. This goes away, and you have x equal to 5. So this is the same thing as x plus negative 8. So to get rid of a negative 8, I have a positive 8. And x equals 12. Okay, let's go on the next one. What's with my x that I do not want? Well, remember, if you add the opposite, that's really a negative 7. So how do you get rid of negative 7? Add 7, which gives you x equals 17. Now, to check your answers, it's the same as it was yesterday. You write the original, you plug in your answer, and then you actually see if it works. 17 minus 7 is 10. Does 10 equal 10? Why, yes, it does. This one has some decimals. No big deal. Same process. How do you get rid of minus 2.68? Add 2.68. Remember when you add decimals that they need to line up. So x should equal 6. Oops. That's why they tell you not to add from the front. 6.70. Now our check should say x minus 2.68 equals 4.02. Plug in your 6.7. So 6.7 minus 2.68, add my 0. I've got to borrow. 10 minus 8 is 2. 6 minus 6 is 0. And 6 minus 2 is 4. So I got 4.02 on this side. Does that equal 4.02? Why, yes, it does. This one's pretty much the same thing. You just got to watch your integers. The only difference here is that your x is over on this side. Still the same thing. What do I have to do to get rid of a minus 5? Add 5. Negative 7 and positive 5 is negative 2. And that should equal x because that goes away. So you have negative 7 equals x minus 5. Negative 7 equals negative 2 minus 5. Now I'm actually going to add the opposite here so that I can see my integers a little bit better. Negative 2 and negative 5 does equal negative 7. So did it work? Yes, it did. This one's a little bit trickier because you've got some stuff going on up here. I'm going to go ahead and add the opposite so that I can see my integers a little bit more clearly. Now, these two things are really the same. If you have 13 negative counters and 5 positive counters, you can combine those to one thing, or you can simplify them. So negative 13 and positive 8 is actually going to give us negative 8 left over. Because if you think about your counters, having negative 13 and having positive 5 on the same side makes all of this go away, and you have this left over. So how do I get rid of a negative 8? With a positive 8. That goes away, and I have x equals 28. This would be a very good time to check your work. (28) minus 13 is 15. 15 plus 5 is 20. So did I get it right? Yes, I did. All right. Make sure to look at the next few pages in your booklet and complete your homework assignment.